Hey guys. Well, I hope. Oh, there he is. You know what, Uri, I was just going to say, I hope Uri turns up today because we're going to be building off the code that he wrote. Because I don't see any share of it in the Reddit. I don't know if anyone else has got it. And so I was kind of starting to think of a backup plan. What if Uri didn't show up today? You know, why didn't anyone share that code in the forums? Because, other people
About that, I'll share it later today. I'm a little bit busy this week.
Okay. Because the sooner you share it, the more time people have to play with it.
Well, you can do it now.
Well, anyway, today we can, we'll start as usual. You can have a general conversation. I can just basically, switch off my camera if you want, and just stick around for about 10 minutes. You guys carry on a conversation. In fact, why don't you talk amongst yourself and find out what what aspects of the language are most confusing to you right now amongst yourself, right? And you can talk and say, hey, do you guys understand arrays good, well, or call by reference, all these things, right? You just toss it around because we're coming up to the final now. And so you can ask each other, I'm solid on this, but I don't know this, or, what do you think this is important? All those things, you can have the conversation for the next 10 minutes, okay? Free form, and I'll basically step away. And then when I come back, hopefully you guys will have some idea of some consensus in the highest ranking topics you'd like to talk about. I mean, I can tell you what we have to cover so far until to the end of CS2A. Basically, I wanted to talk about sorting, which we'll cover today, right? Just introduce you to sorting, the challenge of sorting. And then next class, I'll talk about linked data structures, which is, pointers and memory on the heap and so on. And then we'll implement a linked list next class. That's week 11, first class, yes? Yeah, okay. And then the week 11, second class of the week 11, that's the very last class. That's the last official class anyway, right? So we're not supposed to introduce any material as well. So second week, what we'll do is implement a stack using linked lists, right? Not like you have to do in your Quest in a different way. We'll implement stacks. That will give us a chance to talk about both stacks and recursion and linked data structures and everything else that we've learned so far. So essentially, I think that week 11, that's Thursday of next week. If you don't make it to any class so far, I think people should just make it to Thursday of next week, because in Thursday of next week, we'll basically, I think, I was thinking about it. We cover everything. We'll do one thing. We'll do one thing, which will essentially incorporate knowledge from all of the 11 weeks so far, right? Branching, looping, sentinels, and linked lists, and objects and classes and methods and statics and privates and publics. So all of those, right? We'll cover all of those, and not cover all of those, obviously, right? So week 12, that is basically a review class, right? Because we're going to bring together everything we've studied so far into one project. Meaning that we spent so much time thinking about and learning these things. Is it going to take that much time now? Every time I need to use a particular skill, am I actually looking at that much time, right? So I took about 20, maybe I took 2 hours to implement a stack or something, right? And then later on, I have to do a project in which I know it's a brain dead decision, right? I can just say, hey, yeah, well, in that place in my project, I need to use a stack, right? So that'll happen, obviously, at some point. Now, the question in your mind is, well, at that point, when I say, oh, I need to use a stack, in your budgeting, because all the time, right? Every day, we're budgeting our time, every second of our time. So what we're thinking is, how hard is this task going to be? How much time is it going to consume in my life, right? So when you're budgeting for the total amount of effort that your future project is going to take, right? So you might think, I want to build this incredible thing, and this thing will take me 15 days to build, or 15 hours. Let's just normalize everything and say 100 hours, right? So let's say this project is going to take me 100 hours to code, but of that 100 hours, I know that 5 of those hours, I'll probably implement a stack because I need a stack here, right? Because in my CS2A, I know I implemented a stack and all, and it took me like, 5 hours. So maybe, right? So you're going to think you're going to factor in those hours, but that's not the way it works, right? So I think what happens is that you'll factor in 0 hours at that point because right? So you're all of these things that you do for now and just relegate to your subconscious, they'll become 0 points in your future products, meaning that there's 0 effort involved in incorporating that. And which means that, when you look at your project in future that you previously thought was insurmountable, right? Because you thought, oh, you know what, in order to do that, I have to do so many things. It's not going to be possible at all. Now you look at it with fresh eyes after having mastered these things. Now you'll see that a whole lot of effort has basically just vanished, like, right? Bam, 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 like that. And because all these things that you thought were going to take time, a finite amount of time, right? Because they just disappear, vanish. And then you basically see the finished product. And then you see that, well, you know what I thought was going to be really, really difficult for me to do was actually so simple. I could have done it anyway, right? How could I possibly have thought that this was difficult? Right? And that's what I think people mean when they say hindsight is 2020, right? Because looking forward, you never see it. It always seems insurmountable. But after you've done it, you look back and say, well, why did I ever think that it was insurmountable? And so it's better that since you're going to feel that way anyway, to use a little bit of that to fuel your forward momentum, right? So you can be confident, right? When you approach a task that you see is going to be impossible and you cannot do, right? You can approach it with confidence saying, well, you know what, the amount of effort I need to throw at it is not really that much because I know for sure that at the end, I'll find out it's less than this. So I'll just, take away some small fraction of it. So it'll be less and less intimidating, the tasks, right? As with this mindset. And I think that's why stacks and everything. So that's what I mean, right? So 11, we've spent a grueling 11 weeks trying to build all these little things. And now we know it can be done, but we still think that it can be, well, previously we went from one step to the next step, right? The first step is I have no idea, I have no clue how this is going to be done, right? So it's not possible. I'm not even going to think about it. That thing is not in my reach. I'm not in that league. I'm not even going to think about it, right? It's a different universe altogether. So most of us are in that stage, right? But then at some point you learn the ropes and say, okay, well, you know what? I'm not, if that thing that I thought before was impossible, right? It's not even conceivable for me. Now I know it's possible, right? It's just going to take me a long time. It's right. So you get to that stage. That is a huge first step, right? It's an enormous first step, just coming from impossible to tractable, right? It's possible. So that is incredible. Most people don't even get there, right? So going from there to there, and then think, okay, now it's possible. It's possible because all of these things, there are blockers before, and I thought we're going to take X hours, and I add them all together, it's more than 100 years. So it's not possible in my life, right? Now all of those X's basically became zeros. And so now, or not zeros, maybe some finite quantity, right? Some finite quantity, so that you sum all up, it's less than 100 years, okay? So, okay, well, you know what? That thing which I thought was out of my reach is now within my reach. Right, so it's worth shooting for, but still, it's not that worth it because it's going to take me like 70 years to get there. And by the time I hit 70, I'm going to be old. I'm not going to be able to enjoy life and things like that. Right. So you think that's okay. That's the first step. But what happens is that when you're in that place, if you still don't give up and say, well, you know what, I have nothing else to do. I might as well try and work towards what I want to do anyway. Right. So once you start doing that, you'll see all these problems miraculously disappear. Right. And then what you thought was, previously you can think back and say that was impossible. Now that's possible. It's just going to take a huge amount of time. Right. You go to the next stage. Right. And that stage is more predictable than going from impossible to possible. Now, going from possible to faster is always predictable because that can be done by a machine. That's an automaton, right? Going from that place to that place is basically neural rearrangement, right? So, and basically muscle training, muscle in your brain. You're just training it. So getting faster and faster. Athletes, take marathon runners, right? They don't go run 25 miles in one day, right? It takes a year to build up slowly. And just like that. And you don't look at 25 miles and say, I'm not going to run at all, right? So you're just going to keep doing it because you don't have anything better to do because running is fun for you to do, right? So once you identify something that's going to be ultimately very fun for you, right? And you do a little bit at a time. Because you're not going to toss it away. But when you do it a little bit at a time, what is discouraging to most people is that, well, I've only done a little bit, but there's so much to do, right? And so that's why most people give up and say, well, you know, did a little by little, and the little is not taking me. So that's why I find in my students, anyway, the most productive mindset is to not focus on the grade, not focus on the end at all, because the end is far out there. Or maybe it's not even there, who cares, right? Just focus on the little steps. And now the problem is there's a lot of pleasure hidden in these little steps. But a lot of people overlook the pleasure in these little steps and only focus on the end and saying, I'm going to be, you know, NX happy at the end of N steps rather than X happy at the end of each step. Right? So they never ever, but the N, as the limit of N tends to infinity, it becomes an unattainable goal. Yes? Right? So they keep on stepping and looking. So I think the trick in programming is to not look at your grade, right? That's why, you know, week 10, week 11, this is the best thing to put in our heads, is to say, you know, screw the grades, right? Because I've done Quest 6, I passed this class. Now, from this point onwards, I'm just going to give myself to programming. I'm just, you know, right? And that's the, you know, that's the best way, right? Just if this is something that you're really interested in, right? If you think this is your future, right? Because if you give yourself to programming, programming will just give itself to you many times over, right? So what I mean is that if this is what you feel is in you, right? This is what you want to do. This is just be yourself. Right? And so for the next 2 months, I just dedicate myself, right? So that's the summer. And I'm saying this because summer, a lot of students at the end of summer find out that, well, you know what, when I finished, when I got out of college, I have 2 months of summer and I worked a lot during class. And so I'm going to take these 2 months and just enjoy myself. It's a very common mindset, right? Because I've had that mindset. When I was a student, I've had that mindset. And later on, I realized that was actually a terrible waste. Right? Because those 2 months are the best 2 months for you to basically just sharpen all your skills like crazy. Right? And in order to do that, you can say, well, I'm going to take a vacation for 2 months, but I'm just going to take a vacation from everyone else, right? From the external world. I'm just going to get my bread and butter and water, and I'm just going to sit down and get into what I really love doing. If I don't love it, I'm just going to get to love to do it, right? And it's not like obviously you love it, right? Because you've been here for 10 weeks. So just do it. And you know, and if you are basically your true self, you are being yourself, you're doing what you love to do without bothering anyone else, and nobody will accept you for it, then they don't like your true self, really, right? They want you to play an illusion, which is a different self than what you are. And so if you're able to give it, that's fine. If you're not able to give it, you know, and I think that's why, you know, if your programming is in your heart, the next 2 months in summer, don't waste it. And I will guarantee that everybody here in class, I see, right? Everybody here has promised me they'll basically just, you know, make an effort to pass, right? So I don't care. I don't care that every one of us gets an A, because who cares, right? You know, what does it mean if you get an A at the end of 12 weeks, right? Because you may master all of C++ in maybe by December or the end of the year, right? At your own speed. And when you got to the end, right, all of the asymptotes will converge to the same line. So when you've got to there, it doesn't matter how fast you got there, right? So so the grades really don't mean anything. If you pass, I think this is the best thing to do, right? And it'll also give you a great deal of relief, I think, right? Just getting into some really cool problem and just giving yourself to it for the next 2 months. And then, you know, you will feel that it's not gone waste, right? At the end, because I know, right? If you get into a game, especially today, many games are so addictive, right? So I've seen that you can easily lose yourself in a game, and then you don't realize that until you get out of it, and you say, wow, that was 2 weeks down the drain, bam, like that. I didn't even know where the 2 weeks went. You know, have you had that experience before? Yeah, I've had that experience with many games, right? I've gotten in with a commitment too, with a commitment saying, well, you know what, I'm not going to do more than a couple of hours of this. I just want to see what it's like, right? And then you get sucked in. It's like, you know, in life, we get into a highway, right, and get lost in this town, this jazzy Vegas town, right? And then fortunately, we hit up on a highway that takes us back onto the highway, right? So major roadway. So, wow, I could have gotten lost there forever, right? What stroke of luck was it that I managed to hit upon an exit into the highway again, right? Otherwise, I could have been stuck there. I could have died in Vegas, right? So it's like that. Games are like that. Games are our virtual Vegases, right? So you just get lost in them. And it has to be very careful. You don't have to get lost in them, but I'm saying that once you get engrossed in a game in summer, because this summer, I don't know, right? Engrossed in it, I think it gets harder and harder to tear yourself away from it. right? So you can obviously tear yourself away from it. But I think like the Borg say, the resistance is futile, right? It's not futile, but it gets harder and harder the longer you wait. So yeah, get into programming right now. And I think, this would be a very good opportunity for you. What we're developing in class right now, this game, actually take this game, because I was thinking about it yesterday, and it has like 1 trillion opportunities for bells and whistles. Okay, you can take this game, convert it into a JavaScript game on the web. You can convert it into a mobile game. You have all the logic working. The only thing you need is change something to the equivalent of, display with effect. You've already got the UI part in place. In the old days, we talk about this model view controller paradigm, right? So you have the model which stores the data. The view is what the user sees, right? And the controller is where the logic is. Right. And if you think about it, you don't have to follow that because of the paradigm. But what we did naturally fell into that paradigm. Right. So we have this model, which is, and the logic that works on it. And then, right. And so all of those. So that's what we take this. And I'm happy to help you. Right. So if there's something that I've done, or I have a vague idea of how to approach and do, I'm happy to help you or work with you, or do some research on your behalf. If you're stuck for time, I'm happy with all of those. Okay, so you just have to let me know. Well, what I mean is that if you want to do the same thing in Unreal, right, inside of and release this as a VR game, right, and you want to try and do that, I'm happy to help you, right? So I can show you the steps, get your momentum going in there, and also work with you and give you feedback from time to time. I'm happy to do all of that, right? So just get in touch with me if you are really, really into, right? So if you just, if you don't want to, the best thing is just do it for yourself. And if you really want my help, you can feel free to ask me, right? All right, because I'm only teaching 2 online classes in summer, and there's no formal meeting times for these classes. So in fact, what would be really cool is any of you want to come back in summer and talk to our summer classmates, right? This is my summer students, right? My summer students who don't have any scheduled lectures. Okay, so I can tell them that if they are interested, I have a bunch of 2A students from what is this? This is spring. Yeah, I have a bunch of spring 21 2A students who are happy to come and discuss projects with you, or work with you, or give them pointers and so on. I can set up a time, or a Zoom or something, or or tell them, point them at a Discord channel, and just go here. You find all my spring 21 students and get in there and introduce yourself as a summer student, and then you guys can have a CS2A virtual party, essentially. Yeah, anyone can check in anytime, right? Start a Discord channel like that, and I think that'll be fun. Oh, he's here already. Yeah, I left quite a tweet because there were a couple of them, right? So it was almost like a Waldorf salad without the liquid part of it, right? So it's got walnuts and apples and nuts and. Well, let's see if the other guy comes. I want to see if they share. This is this is an experiment to see, because every time I give him something, and the both of them are there. If there's 2 of them, if I leave 2 nuts around, right, and the 2 of them are there, the first person to get there will take all of it, right? You wouldn't say, we came together, I'll take one and the other person can take the other, right? So Peter and Ash, well, these are not Peter and Ash, they're Little Peter and Little Ash, right? So and so I left a lot more this time to see what they do. Well, or at least, one person won't take everything. But I had this problem before. When I gave them lots of nuts, they wouldn't eat here, right? They just go and dig lots of holes in my garden. Right, and then I spent a lot of time covering up all the holes. Then I came up with an ingenious solution, but still all the same. Now they don't take it and run away, so they don't bury it. So just eat it here, or it goes back in the cupboard. All right, great. Okay, all right. What time is it now? Oh, it's 8:20. So I think we're good on time. How many of us are here? I think most of us are here. A couple of regulars are missing. Yeah. But I think I got a few emails actually saying that a few of you can't make it, so that's good. All right, so we only have 3 more classes, so make the best of it, I guess. We'll try and anyone can pick up the screen. The only thing we need to do is just pick up the code we had from last class, and what was the I think we got to a stage where we 2-string. Yeah, we wrote a 2-string for the team class. Yeah, we wrote a toString, and then in our main, we printed a lot of teams. So yeah, let's get that program up. And then what we'll do is now, here's what I'm thinking, okay? And obviously, I may be wrong, and we may change direction as we're coding. But here's my rough plan. I'm thinking that we'll take that code, drop display with effect. Yeah, we'll drop display with effect into that. And and then we'll create a game class which uses, yeah, we'll create a game class that uses the this thing, okay? All right.
Display with effect in my machine doesn't work. I think it's just the way that my machine compiled the code for some reason. But in a Windows machine, it works fine. So anyone with a Windows machine should be able to run it.
We'll fix it. You know, don't worry if there are any problems at all. We'll just fix it as we encounter them. So I wouldn't be worried too much.
I mean, I've tested the same code. I've tested the same code in Ripley. I tested the same code in Windows, and it was working fine. But I'm just running some tests in this Linux machine, and it's my main machine right now, and it doesn't run the code even with 3-letter words.
Well, do you want to share your screen? We can debug it together. Would you guys like it? Hey, if other people are okay with it, we can try that for the first thing we do today. Right? Is everybody okay with this? Yeah. Okay. Hey, Turkey. Yeah. Good.
Awesome. I'll share my screen. Let me just pull this up. And I think I can test it here because I have a main here.
Oh, you have the file open. Hang on. Okay. All right. Good. All right. So let's see. Display with fact. Well, true. And what was happening? Well, what was going on? So you're going to run it now? Okay. And what's going on? Oh, it's not. It's. Oh,
it never finds a sentence.
Oh, I see. All right. It's quite easy. All right. Just put an int before the main first. Let's get rid of the warning. Inside. Yeah. I'm going to put. And it's not, and you're saying it's not terminating, right? It should have terminated by now. So why? And you're saying your question is, why is it not terminating? Right. Yeah, so let's take a look at the program. Let's take the code that does the thing.
Okay, give me a second.
Oh, you know what? Here's, I think, one of the reasons. Okay, it's just a hypothesis, and maybe we'll find out, right? It's a hypothesis, and like science, we can find out and test it, right? My hypothesis is that the random you're generating on the Linux machine is probably a 64-bit random, not an 8-bit or 16-bit random, right? A 64-bit rand is enormous. And therefore, the rolling of characters into place is still going to happen, but it's going to happen after a long number of, huge number of rolls, like, trillions and trillions of rolls. So it's going to happen. I think that is my hypothesis, right? Because the logic, I'm thinking about the logic. I don't see any error. So here's something you can do, right? So where do you go size rand equals? Where do you have this rand equals?
I think it's...
No, in your display with effect. Where's your display with effect? Where do you assign? Oh, right, rand, right? So do it. No. Go to that line. Go to that line. Do a percent 100,000. Right? So, no, not there. At the end, before the semicolon. Yeah. Now I do a percent 100,000. Right. And when I do 100,000, what I tend to do is again, this is just a trick, right? And you don't have to follow this. Any number greater than 1,000, I write it as a multiple of 2 or more tens. Right. So not tens or here. For example, I'd say 100 times 1,000 rather than 100,000. And the reason for that, as most of you who now try to reporting trolls on forums, right? O and 0 and L and 1, very hard for programmers, people to distinguish in different fonts. So and also count, right? So I would say, no, 100 times 1,000, rand percent, 100 times 1,000, put that in parentheses. Right, so that then people will know it's 100,000, but they don't have to count the number of zeros to figure out it's 100,000. Does that make sense? Yeah, but someone could say, hey, you're making the computer do more work. That's something that humans could do. You say the answer to that is no. That's not what happens. What happens is the compiler will turn that into 100,000. Right? We're actually making it easier for humans to say 100,000. All right, good. Now I think it should work. Right? Previously, I think it was generating a big ass random number for each one of those.
Yep.
All right, cool. So that was my hypothesis, and I think our test actually proved it. So, was this a cool exercise? I actually loved it because we had a problem. We formulated a hypothesis, just like in science, right? And then we tested it to see if the hypothesis was true. Because if that wasn't the case, we would have found it by now. And I believe that is the case. However, we still don't know if my hypothesis is true. This only corroborates this. So real scientists at this point, what we would do, we're not going to do it, right? So I'm saying what we would do to ultimately, put the final nail in the coffin, as they say, right? So what you would do now is, okay, the hypothesis that, the RAND was big ass is now confirmed. Let's get even stronger and say, let's actually really find out what RAND returns. Right? So there's two ways to find out. One is to do just a man on RAND, right? So just Control Z on the Linux box. Yeah, right there, I think in your terminal should work. No, right in your terminal, right? Type man space, I think it's -S5. It's in the 5th section of the manual, right? I think so. Space 5, 5. No, 5. No, 5, number 5. And space, RAND, RAND. I think it's 5 or 2, one of those, right? It's such a long time since no manual entry for RAND. Just get rid of the -S5 altogether. Oh, maybe VS Code is just giving you a really, really stripped down version of Linux in that box. Hit return. No, man RAND and return. No, RAND. Oh, okay, RAND exists. I think it's man S2 then, man S2. I will try man S2. Oh, no, it says, I don't know, in one of those places, we can actually find out what value RAND returns, right? It'll tell you. Well, you can follow this, right? Or you just go to Google. The problem with going to Google is that it won't tell you on this architecture, right? So, but there's a way to find out. You can find out what RAND returns. No, you can't say it's -S. -S is the saying section. -S. No, you got to say -S and then 2. I think 2. Space RAND. Yeah. No, I don't think so. Yeah. I don't know, maybe 7. I don't know. Let's not waste time. But essentially, that's what you do. The other way to do it is basically just print out, right? Yeah. The other way to do it is just print out the value of RAND and say, hey, I just printed a whole bunch of randoms and look, they're all big numbers. That's another way to lend corroboration. Well, the ultimate proof, of course, is to just look at the source code of RAND. It's all open source, right? Just go to the Linux source code and look at the standard library source code, and you'll see RAND. And RAND is probably like 15 or 20 line program. Well, obviously, it's RAND. We say it's a 15 or 20 line program, but enormous amounts of work has gone into those 50 because generating a random number is not so simple. You think about it, right? Anything you do, toss a coin. Anything you do, it's not uniform. Right? Eventually, it all settles down to a bell curve, Gaussian. That's a central limit theorem, right? If you take any damn distribution, right? 3 random numbers in the distribution, add them together, you're going to get a normal distribution in the end, right? So that's a central limit theorem, and yeah. So generating uniform random is so hard. That's what I mean, right? It's so hard, and so when you call RAND, what happens is that they don't generate the random on the fly like that because we're calling RAND so many times. Imagine how expensive it'll be, right? To generate a true random. So what happens is that these randoms that you get when you call RAND have already been pre-crunched for you ages ago, right? Some massive computer sometime ran for a very long time maybe, right? And then spat out a uniform distribution of a long list of numbers, okay? They took that number list and saved it in a table. And that table has now made its way into all of these machines that we see, right? So when you call RAND, all it's doing is saying, I'll give you the next number from the table. It's not generating a random for you. So how many of you knew this already?
About the RAND?
Yeah.
I mean, I figured because when I was trying with the names, I just added like the as a string and it was figuring out the first 3 letters or 4 letters after a while. Then anything bigger than that, I figured like maybe
Oh,
the
not with this, not with this. No, I was thinking about, I was talking about the history of RAND, right? How many of you know, are familiar, because you didn't have to know, right? You didn't have to know that, what were we talking about? This RAND, yeah, I don't know. I think there was this interesting curiosity about RAND that I mentioned that I've forgotten now.
Is it the same? Because sometimes when you run RAND without declaring the RAND S, it's the same numbers.
Yeah. That's right. Thank you, Turkey. Yeah. That's what I mean. Yes, it is. It's all pre-computed. It's the same numbers. It's stored in a table. Every time you call RAND, you're just getting the next number from the table. It's not really generating a real random number. That's why they're called pseudo-random numbers, not real random numbers. Well, technically speaking, even the original numbers were pseudo-random, right? Because, you know, you could argue that they were all the result of some deterministic process that we can't quite capture just yet, right? So that's what called pseudo-random. But, you know, that was a very long digression into random and what is random and all, because, you know, it is also a topic that I'm very fond of. It is one of the topics that, you know, I did my PhD in. What actually constitutes randomness, right? What is information? What is information, right? So when you go to the races and pay someone who gives you a tip, right? When you go to the races and pay someone who gives you a tip, and that person says, you know, blindingly fast filly is going to win the race, right? Okay, well, you know, I don't know how much that tip is worth, but if that person says, you know I've got some inside information that there's a lame ass dodo is going to win the race, okay, and then you pay the person a lot of money because they gave you something that was highly unpredictable. Yes or no? Yeah, okay. So now you actually have a way to quantify information, right? Previously, you didn't have a way to quantify information, right? If someone asked you, you know, how much is this information? How much is this information? You had no way of telling, right? Gold and everything else we buy by the kilo and pound and everything, right? So everything has units to measure. But information, does it have units to measure? How can you tell, you know, this is more information, this is less information? Right? Now, here's the intuition, right? So we just talked about the intuition into how you can actually quantify information, just like any other quantity. So you can actually sell information, right? And we say that an information, the value of the information is directly proportional to the log of the, you know, it is related. It's related to the amount of surprise. It's surprise it gives you. If someone tells you something that's really, really surprising, you got a lot of information there. Right? If someone tells you something that is, you know, you already know for certain, right? It's not at all surprising. Probability 1, right? It's definitely going to happen. The sun is going to rise tomorrow, something like that, right? There's no information there, zero information, right? So using that intuition, it's actually possible to say, to quantify very, very precisely exactly how much information is contained in an event, right? By saying the information, the amount of information is directly related to the probability of the event. If the event has a probability of 0, right? It has infinite information in there. If the event has a probability of 1, it has no information in there. Does it all make sense? Yeah, okay. Well, anyway, what I told you is just basically the basis of information theory, right? So, and that's what I did my, PhD. And it's a very interesting topic because, it has so many ramifications. It applies to everything. It's not just it applies to everyday life, right? Living a life that is low entropy, right? So, and because entropy is high, you learn all this in thermodynamics too, right? It's, this is the amount of disorder. Entropy is the amount of disorder, right? Because you can bring that to bear in the information theory context also, right? Because if something is highly unpredictable, very little chance that you'll get the right thing, right? Too much disorder, I can't tell. Right? Who is good and who is bad, or who is not, what is good and what is bad, right? So then too much disorder, high entropy, right? However, we want to be able to tell what is good and what is bad. So if it's high entropy, I can. The way to get it to be able to be good at being able to tell what is good and what is bad is not by getting really, really good at operating fast. Right? Because things change so fast, I also need to be really fast in order to go with it and then, and hit the mark. Okay, that's one way of doing it, but it's a really hard way of doing it, right? The other way is to say, well, things are really, really fast. I can't tell what's good and what's bad. I'm just going to wait, right? Because most of the, fluctuation is caused by me, right? If I just stick around and wait for it to get still, now I can tell which is good and which is bad. Yes, so that is basically information theory in action. And we're saying, right, and that's machine learning, essentially, right? Machine learning is essentially teasing out the pattern. Guys, many of you are going to go on to do data mining and machine learning and artificial intelligence in the future, right? If you think about it, all of this is basically teasing out the pattern from noise. Because data is free. There's data everywhere. So people say we have a lot of data. Come and join us and work with us. What are they saying? You know, really, there's data everywhere. You know, you can get data at the drop of a hat now. So really, the exciting part is saying that, you know, there's data and there's also these interesting patterns that we already have some really good hooks on. We just need you to come so we can excavate more and uncover these patterns, right? And that's where the juice is. And so information theory, the mindset, the information theoretic mindset, right, permeates programming, I think, right? It just permeates programming in such a way that this economy of thought, economy of cycles, economy of effort, you know, the maximum laziness is basically driving all of this. Low entropy, so that you just make everything as settled as possible. Because it's very hard to find a bug, right? It's very hard to find a bug if too many things are changing. That's what you do, right? The fine art of debugging is to find out how to settle everything so that only one thing is changing. Yeah? Because if too many things are changing, it's very hard to find the bug, right? You have to do multivariate analysis, right? So the univariate analysis is where we're going so that we can settle everything else and find the one thing that matters. Okay, all right. What time is it now?
8:37.
Okay, great. So great, thank you so much. Is everything ready to go now? We can actually take a look at it. All right, great. So let's run it once. If anybody has any questions, let's review the code. You guys want to talk for now, for a few minutes?
I do have an input in the team file.
Okay, let's finish it, get it to run. And after it's running, after we get the main running, before we actually start working, I'd like to step away for 5 minutes, let's say, right? Just maybe 5 minutes, because I want you guys to just go over this code amongst yourself, right? Go over scan, scroll, everything, right? And make sure you're all totally solid on this, and then we'll take that to the next level. Is that okay with you guys?
Yeah.
Okay, great. All right, so let's debug this. So toString, why has no toString?
Let me make sure I have the latest file, because I just copied this from the Reddit. I've seen a zip file in chat.
Well, we can fix it. If you got most of it, we can fix it. Don't worry.
All right.
Okay. So team.toString. This is okay. This all looks okay. So where's your team class? Where's your team class?
Team class.
All right. Okay. toString. Where's your toString declared? I didn't see it at all.
I think it's in.
Oh, I see. That's why. Maybe it doesn't see. Where's your CPP file? Where's your team.cpp file? Maybe it's there. Is there a toString there in here?
Yes. It's
yeah. Okay. I just triple click on the line. Line 43. All right, copy it and put it in the other one.
Team H?
The header file, yeah. And I think we got rid of a couple of those other things, right? Vector contains and set size and set musical names. All of those are gone, right? In fact, there's only two public methods, only team and then toString.
The file is in chat. I'm just downloading it so I can just copy it.
Yeah. Actually, yes, you're right, Tricky. There's more things to be changed. I think there was a contains method. Yeah, okay. Reduce the size. I've only got like 3 of you now. All right, now I've got more of you. Maxim, are you here?
Yeah.
Okay. How are you? And I think I saw you before. Isaiah, are you here? Okay, so everybody who's not here, has to watch this video at some point. Okay, so it's on YouTube, but I don't know if people are getting a chance to watch the video and follow along. Also, I think if you're watching it on video, what are the chances you're going to code along, right? Right now, when I forgot who's coding now. Who's coding, by the way?
I'm coding.
Oh, Turkey. Yeah, right now Turkey is coding, and even though you're not coding, at least you're mentally coding with him. Yeah, but YouTube, I don't think that happens, right? Because I watched a couple of those videos on YouTube also, right? I don't think the coding thing is really helping because you're watching it and it's like a movie, right? You're not even coding actively in your head. I think the reason probably is because you know the ending. It's like the Game of Thrones, the ending is already there, right? So you know it's going to end, you're not going to follow along. You're going to say, okay, I'll just watch the ending. And that it's not working at all. So I don't think that's we've got to find a way to make sure that this kind of thing doesn't happen with the YouTube videos, right? So the YouTube videos also maintain that kind of suspense, saying, well, you know, we're doing this, maybe we're going to have a bug. Maybe Turkey is going to run into something and then we're all going to fix it together. That feeling never happens on a YouTube video, right? So that's why I think that even if you're you know, not paying attention in class, but thinking that you'll catch up with the video, I don't think it's going to help. Okay, so maybe next class, the next quarter, I'll make it very clear to the students also, not in summer, in fall, saying that you know, the YouTube is only the backup source. Okay, it's not a substitute for the lectures. So if people think that they can just watch the YouTube videos and not come to class, they're just missing out on a huge bunch of stuff. Because once it goes on YouTube, there's no reason you need to watch this, right? There's a ton of other videos on YouTube. Yes, this is, if you take C++ programming, every university's got free courses, and they're all putting on YouTube, right? So there's so many courses that you can do on C++ or any programming. So there's no, once it goes on YouTube, the value is gone. So the real value of this class is live coding and following with a live coder in class. So that's lost in YouTube. So YouTube should only be seen as a backup, I think. Maybe I should even stop uploading these things, right? If you don't come to class, you basically miss it, right? I think maybe that will be a better way to do this. I don't know. We'll think about it. So why is it still not there? It's not being linked in. It's not being linked in. Oh, yeah. Well, team.cpp. You're not including. No. Get there. Yeah, team. No H. You don't have the H file is included. Yeah, those two. Yes. Good. All right, so different. Get shuffle players. Oh, we haven't implemented it. Expert it. So we started doing this, and you got this file from someone else?
Yeah, I got it.
Okay, good. So this is the most up-to-date file. Now I remember, because this was the very, very last thing we did in that file. Was we said, well, let's get started on that function, and then we didn't implement it. Okay, good. Let's go to the file. Let's get rid of the function and run it, and then I'll give you 5 minutes to basically just. Yeah, so just comment it out for now. Just comment it out. And then I think it's also there in your CPP file. There's also, I think there was some reference to it in the CPP file. Yeah, comment that one also, yeah. All right, good. All right, so it should work now. Yes, it should. I bet it should work. It'll work. And increase the size of the console also so we can see what's going on. No, I mean the vertical size, because we don't need the code anymore, right? Okay. All right, so we have these guys. You know what? I changed the player length to 4 instead of 6. I think 6 is first of all, it's hard to pronounce, and also second, I think it's
it doesn't give duplicates.
Yeah. It doesn't give us that other case that we built in. No. You're saying you have 10 teams of 10 players?
I mean.
Yeah. I'm sorry. Yeah. So you want teams of 10 players, and each player has a length that is. No. I think we used. Did you change it the length of the name to 4 in the team.h file?
I don't think I did.
Oh, name size is 4. Yeah, great. Okay, and max team size is 6. Okay, so it should get to set to 6 anyway. Yeah. Okay. Great. Oh, why are you getting 10 teams? Oh, I see. We're doing. Yeah. I'm just mixing up too many things at the same time, right? They're maybe thinking about too many things at the same time. Why is it still getting 6? 1, 2, 3, 4. 1, 2, 3, 4. Oh, it's 4 syllables. 4 syllables. I think we should make it 2 syllables. Okay. Oh no, make it 3 syllables. 3 syllables. It will be good. 3 syllables. I think will give us nice names. And also in the make the name thing, let's capitalize the first letter. You know, it'll look cooler. Right? So make that 3 syllables, and then you have a make musical name. Go into your make musical name private method. You know what? This is VS Code, right?
Yeah.
I think it's when you're in a header file or anywhere in the file, and you see a function called make musical name, and you want to see you want to go to the body of the function to change it. There is a hotkey for that. I think it's Control click. Right? If you hit Control click, it'll just open the right file and go to the right place in the right file automatically.
Yeah, it does.
It does.
Yeah, I just did it.
Oh, you did it. Oh, I thought you scrolled into place.
See, Control, click.
Oh, but I thought you scrolled into place before. Anyway, never mind. Yeah. Okay. All right. Yeah. All right. Cool. So yeah, let's also take the first letter of the name and uppercase it, right? So before you do a return name, say name of 0 equals, before you do the return name, space, and say first name, name square bracket 0 equals, I think it's 2 upper, right? T-O-U-P-P-E-R, T-O-U-P-P-E-R. Yeah. And then name of 0.
Professor, that's just gonna uppercase the first letter in the name, right?
Yes, that's all we're gonna do. Yeah. Thanks. All right, and put some spaces around the equals, and we're done, I think. Right. All right. Now, is this all we want to do? Yeah. Now it'll give us the names that we're after, I think. Try it now. Try it now. Run it. Yeah, okay, it looks better. Why is it not capitalizing the first letters?
Yeah, it's not.
Yeah, let's go back. At least we're getting these things, funny things, right? So with the 7 and all. Why is it getting 7? It's really funny. So maybe there's a bug, okay? Unlikely. But 2 upper is not...
I mean, name.0 should be a character, and oh, this one is receiving an int.
Yeah, but that's okay. But name of 0, try this one, okay? Instead of name of 0, no, not there. On the left-hand side. Why is it not working? So can we debug this at all? Is it okay? Can we stick a debugger? Does your debugger work in VS Code, or do we need something else?
I don't think my debugger works, but I can try it.
We can GDB it too. It doesn't matter. No, let me just run through this in my head 1 sec, okay? So we're just building this. Name of 0 is 2 upper name of 0. So it has to, the first letter, and then it is returning that string. Where are we calling this make musical name? Just go back to the place where we're calling make musical name. Yeah, let's get rid of the debugger window, right? So yeah, make musical name, okay. All right, so where are we calling this? We're calling it somewhere, right?
And
get rid of the function. Get rid of the function set musical names. I don't think we're calling that anymore, right? We don't need that. That function is gone, right? And also set player names is also gone. I think we're not using that, right? It's only being done inside the constructor now, right? Yes. Set size is gone too. We don't use set size. Yeah. And then we don't have something called check double, right? We don't have something called check double. We have a contains method, if I'm not mistaken, right? Do we have a method called contains, by the way?
I think it's in, it was in main. No.
What happened? So this is not the most recent file then? Where's team : contains? I'm pretty sure we wrote a team : contains. Yes or no? Am I hallucinating here? Can you guys help me out?
I am pretty sure we did. It's called contains.
So where did it go? Because I saw the later changes, but I don't see the earlier changes. Where did team : contains go?
Oh, it's called contains _ contains.
It's a private method. It's a private method. Where's your header file? Where's your header file? It's not even in your header file. Oh, there it is. It is in your header file. So where is the CPP? Where is the CPP file? Oh, there it is.
Oh, I have another team CPP. My bad.
Oh, geez. Okay.
That's why. Right. Okay.
Oh, because you're on a Unix machine and it's case sensitive and all. Can you just clean up your directory, because you don't want it to be accidentally changing this. Yeah, clean up your directory. Name of 0, right? And I think your compile line was didn't complain. Your compiler didn't complain because it found the lowercase t, right? Get rid of it so that even if you have an accident, the compiler will catch it for you, all right?
Okay, I'm getting rid of it from the file manager.
Yeah, you got rid of it?
Yep.
All right, great. Okay, so go to your console. Do an ls-l, by the way. Just do an ls-l. Yeah. Okay, all right. So what you have temp code runner file.h. Get rid of that too, unless you need it, right? So you just move it somewhere you want. So this directory will be clean, and you not we can put it in there. So just rm. You can. Oh, it's gone. Okay, good. All right, good. Now you should be able to do the G++. Now it should print uppercase names, right? Oh no way. Semicolon.
Missing a semicolon.
Thanks, Turkey. All right, so yeah, we had to digress there a bit, and excellent. All right, great. I think it should give us uppercase names now, right? Uppercase first letter. Yep. Great. Okay, and the names look better too. We don't have any numbers. CSA is still not generating any duplicates, right? They're all.
We didn't lower. We didn't lower the syllabus yet. Oh, we did.
We didn't know. It also looks good. That's fine. We don't care, right? We don't need to. But I'm pretty sure if you do 2 syllables, we'll get duplicates for sure. Okay, do two syllables, right? You'll get duplicates, but we'll put it back to 3 because in our game we actually 3 looks better. Put it to 2. I'm pretty sure you'll get duplicates now. There you go, right?
2.
Sorry, 2 and yeah, sorry 2, right? And so on.
And Lafa 9, Fala 6.
Oh, you know what? Yeah. Basically, yes. It's it happens to be. Oh, wow! This is a dead ringer, right? So basically, the number at the end tells it the exact position. Not even if generated before or after. The number says, "I'll tell you where the final position is," right?
Yeah.
Yeah. Okay. All right. Well, we can fix those things later. Okay. All right. Put it back to 3. We're good. Right. So I think what happens if we get a duplicate, the duplicate is basically a freebie for us. The duplicate always goes in the right place, and then we get 1 player less in that team.
Awesome. So at this point, do we include the display with the?
Oh yeah. Go to your package explorer, your folder. Okay. And then so we're going to start working on this. Is everybody okay with this? Right now, here's the time. Wait, what time is it now? Okay, it's 8:53. Okay, 8:53. How about 3 minutes? Okay, we'll start shortly before 9. You guys want like until then to basically discuss this code. Some of you probably blindingly obvious, right? And Turkey, he wrote it too. So some of you maybe, right, kind of fuzzy here and there. This is your chance. Okay, if you're in a heated discussion, I'm not going to interrupt at 9 o'clock. But if there's silence, I'll come back at 9. Is that okay? Is that okay? Yes or no? All right, I'm seeing 1 thumbs up, 2. All right. Okay, Mark is rolling his eyes. Hooray, okay. All right. Well, you guys can call me back, okay? Call me back if you need me to, we'll pick up this code. But this is where we're going to start, okay? We're going to pull in display with the fact, and then we'll start building a game, which is going to use this, okay? So it's all going to be very simple from here on. But this you need to, I think, spend a little bit of time on, okay? So I'm just going to be around and call out to me, right? 9 o'clock. Either way, call out to me at 9. Yeah, you have a question? All right, good. All right, just call out to me at 9 o'clock, and I'm going to be here. Right, thank you, guys.
Awesome. So the display with effect, what do we want display with effect? Because if you display 10 teams with effect, it might take a while. So do you guys want to try it just with 1 team?
Oh yeah, we should just try with 1 team first.
All right. I'll show you the main that I used for display with effect, so we can see how we can ask for the function.
Hey, by the way, sorry to interrupt. I just want, before I go away, the one thing I wanted to mention was because Turkey brought it up. We're not using display with effect with this main. This main is basically, we're going to delete this main. This is not this main. We wrote this main just to test to see if our toString is working. That's all we're doing, right? What we're going to do today is essentially build a game class. Right? We'll build a game class, and that game is going to interact with the user, saying, hey, I've given you a random team, right? With these are the players of the team, right? No display with effect here, okay? These are the players in the team, but this is not the right order. You can ask if it's the right order or not, right? And then the player would say, oh, this is a shuffle list of players. I want to face off players 3 and 4, okay? And then that's where we, right? And then 3 and 4, this game will now be able to compare. Ask the team because the class has, right? It can tell who's better. So it'll ask, and if it's not right, it's going to turn these, right? That's the time when the result of the user's interaction is known to give the result back to the user. That's the time we can use display with effect, right? When there's a tournament face-off, we can say the winner of the tournament is, right? And there you can use a display with effect. Yes? Okay, so we
Yeah.
don't have to use it everywhere just because we have the effect, right? So it is cool. It's cool that we saw that it works, but we don't have to do this anymore. Okay, so I'll be back at 9:05. Okay, so 9:05, just feel free to talk, or if there's silence. Okay.
All right. So we create a class called game so we can interact and manage the team, I guess, and choose someone randomly against the other. Is that how we are doing it?
I think so. Is there any like code that some people like don't understand? Does anyone have any questions about the code?
Nope, it's running.
No.
Actually, one thing I wanted to change in the code, this section with the if. I was thinking we need an else here.
Else?
Yeah, because you have two things to do, or should we not have an else? Because what if the size was more than the maximum number size? Then it was equal default team, then back into the size.
Well, this is only going to trigger if the size passed in is bigger than the default or the max team size, right?
Yeah, so we need an else here because if it wasn't there, imagine if size was bigger than else team, but we'll just get back to its original value.
I guess, yeah, we could just leave an else there.
So where should I create the class? In a new header, maybe?
What was your question?
Where should I create the class for the gaming?
I feel like it should be in the header file, right? And then we define the methods in the .cpp file.
So it should be in the team H, or should we create a new one called game?
I feel like we should make a new one, right?
Should we do pragma ones?
I forgot what that does, right? I forgot what that does.
It just prevents the includes from looping on other includes, if I'm not mistaken.
Okay, yeah. Then.
So you typically want that.
And
then you need that if not defined, then define the game underscore H.
should we include the header for the team and the game? Because the game is what's going to manipulate. Or it should be in the game CPP, I think. Or do we? I'm grabbing a piece of paper, sorry. So we have a main that should call the game function. And in the game function, we should call creating the teams from the team H and team CPP. What do you guys think?
Mm-hmm.
Or is it too much?
Yeah, I think we need to include the team H in the header file, right?
Is that what f and def and define is for, or not?
Oh, I think you need to change that if not defined to game underscore H on right in your game H file. Yeah, and at the bottom you need something. I forgot what it is. So go back to the team H file, and then go all the way down, and then you need you need that end if, and you just need to like copy that syntax. So it'd be exactly. Then you can create cool.
So what should we do in game? Should we just pick two randoms from like two random values from the team H, which is sorted players at this point, right? So we take the instance that the class like instance that created sorted player from H, maybe.
Wouldn't we need to include team.h in the game H file? So you could use the data members and the methods of the class.
So what are we doing in the game? Are we just picking up two random players from each team?
I think so, right? That was the plan.
So we have two players and two teams. So I'm gonna guess maybe the private values should be team 1 versus team 2. So we'll literally just pull up this vector. Instead of saying sort of player, we say team 1. Can we declare it like this?
I think so.
And we do the same thing for the, because next we're gonna pick up a player 1 and a player 2. Should we do it as a string?
Do we have we don't have a player class, right?
No. Yeah, we have a team class, we don't have a player class.
I guess, yeah, would you just use strings to, like, for the name of the players? So like string player name or something like that.
So player.
But yeah, just that, yeah. Just for player 2.
Should we make a method called select players, and that should be private? And the game should be public.
What would that private method do?
Just pick up a random like a random item in the vector team 1 and assign it to player 1.
Yeah, I guess, yeah, that should be private.
So should be void?
It'd be void because it doesn't return anything? Or it returns
no.
a player, right?
Oh, it returns a player, you're right.
So it'd return a string, right?
So std string?
Yeah, std string, and then
player selector.
I guess, yeah. And does it take it anything?
It should take team. It should take the strings from. It should take the vectors from teams, but should we? Let me check here. If we ever took a vector, I think because it's in the class. Well, yeah, we need to assign them. So we need to pull them out of the team itself, then assign it. Therefore, we need to pass it by reference. Right?
I think vectors are already passed by. Oh, no, that's arrays. So yeah, so you need to pass it by reference. So it's gonna take in two teams, two vectors. And it's gonna select.
Oh, sorry, here.
Are we gonna be allowed to return two strings?
I think you can assign them inside the function, but like the same way we did with sorted players, like we never, yeah, I'm a little bit confused. Oh, sorted players, we returned it back in,
Server players returns the vector, I think, right?
yeah, and we kept adding it here, see, and we didn't call it in the declaration. And it just took it normally and just assigned it with no problem, and even resized it too.
Mm-hmm. That's setting the name for each index of the vector, right?
So I'm here and I can join anytime you guys want me to, but I'm not going to butt in. Okay, so let me know. So
yeah, you can join because we're a little confused.
Yeah, is that okay, you guys?
Yeah.
Yeah. All right, good. Let's take this program. I'm gonna. Some of you are going to drop off screen. Okay, so I'm going to reduce the size so I can see the font. That's more normal size font. Okay. All right. Great. Oh, so you guys went ahead and created the game class. Hey, that's great. That's great. Thank you. Thank you. All right. So our game. Here's what I'm thinking, and you should just correct me, right? Because I'm just thinking off the top of my head. So our game will have a team assigned to it, so, right? And the game consists of determining the right skill levels of all the players. Okay? So in order to make this game-like, let's go to the team class first and take that toString method and make that a private method. So people are not allowed to see the real, right? And then make that underscore, and then do the indentation. And also you can separate that from the previous method, because you can group these methods differently later, okay? Because I think, some of these belong together and some don't, and you can chunk them up as you like. Okay, all right, now since it's, thank you. So that's gone. However, if I'm the player of the game and I've been given a team, right? I'm the manager, right? The managers are players, right? So I've been given a team. I need to know at least who the players are. You don't have to tell me who's better than who, but you got to tell me who the players are. Yes? Okay, so let's create a method saying get shuffled players in team. And that's the only public method we'll have, right? To get some visibility. We'll have a couple of public methods. No, that's not private. It's going to be public now, right? Under the constructor. Get rid of, Oh yeah, we actually had that. All right. Now let's implement the body of this method, right? So put it in the public section and let's implement the body. All right. Now this body, all it's going to do is, well, we already have the players, except they're not shuffled, right? Now I'm going to take that and shuffle it and give it to you. That's all it's doing, right? So just take, so say vector of string. We're going to create a copy of a vector, right? So vector of string. And because these are small vectors, we don't care about creating copies of vectors, okay? Anytime we have large vectors, always be careful. And I don't know, you got to develop a thumb rule yourself. If there are small vectors like 10 or 100 lines even, I usually don't feel that uncomfortable by saying one vector equals another and copied over. But that's a very fine line, and you got to find that for yourself and your program and the scope of the program and things like that. Some cases, it is not advisable to do this. So if you have a large vector that you need to construct and pass back, don't make your own vector and pass it back. And then you're creating a copy and then you're passing a copy of the copy and they have to create a copy of the copy. It's a real pain. So if you're passing a large vector, the right way to do it, again, this ropes back to 2 classes ago, right? The right way to do it, if you want to fill in a large vector, is to have the caller give you the large vector by reference, not constant, right? And then you fill in the large vector and say, I'm done. That's much better. Here we're doing these many copies only because it's a small vector. Is that okay? Because what I'm doing can be a bad practice, right? Can be arguably a bad practice. If we do this unthinkingly and say, this should be fine because we did this in class in CS2A. This is bad. It's a bad idea. So I'm very happy that we actually had an opportunity to let's tag it with a comment because it's going to be in a video. Maybe some student will unthinkingly follow this, right? So put it in a comment up there saying, normally we do this here, but large vectors should not be copied willy-nilly like this. And I think it's 2 L's for normally. And then also say note to future student or note to something, right? Note to future student. I don't even know why we're doing this, right? Because we were thinking of phasing out the YouTube videos. And, but anyway, no harm in being nice to them. So we should say, yeah, note to future student, right? Just put a note to future student. No, not note. Okay, not note. Okay, all right, good. So vector of string, let's say shuffled list, right? Space shuffled list or shuffled players or whatever it is you want to call it. Yeah. Equals. Equals. And then say your, this dot players. Yeah, sorted players. Yes. Okay. Sorted players equals sorted players. Now, sorted players is fine because it's a method. You don't need this dot, right? And in fact, it's not this dot, right? It's in Java, it's dot, and here it's arrow, right? So yeah. All right. So put some equal spaces on the other side of equals. Oh, it's all there. It's good. Right. So we've created a copy. Everybody okay with it so far? But it's not shuffled. It's a copy is the same as a right. Now we need to take that and shuffle it. Right? There is a method in the standard library called shuffle. So let's open up a Google or something and say, or even a man page here and say standard shuffle. What are the arguments to standard shuffle? So can you go to Google and find out what the, I think it's standard :shuffle. And then the arguments are vector.begin and vector.end, but I may be wrong, right? So just Google and find out what the correct syntax is, and then we just call it and return it. That's it. Are you doing it right now, or anyone can do it really, right? Open a browser and say, what are the parameters to standard shuffle? And if you got the answer, just walk us through it. Oh my gosh, my camera is not on. Sorry, I'm here. But obviously I was talking, so I was present. It was not a recording. There's a very interesting video I saw of some guy posted a video of himself. You saw that? You saw that in a Zoom meeting in a technical company, right? In a big company, in a Zoom meeting, he said sent a recording of himself, and nobody could tell. And it was even asking the right questions at the right time and so on. And
Professor, there's two of them. There's a random shuffle and then there's just a shuffle.
Oh, there is? I didn't know that. Hey, Chris, so it doesn't matter which we use. We just need to shuffle it. And just walk him through one of those.
No,
I think standard : shuffle is a method. Or maybe Chris was saying random shuffle. What is it called? Random shuffle?
There's a standard shuffle, and then there's a.
Well, what do you want us to use? Do you want me to look it up, or is someone gonna say what we want to use? I can look it up quickly if you want.
I think the shuffle I have is not for vectors. The standard shuffle for some reason.
Right. So just Google for how to shuffle a vector and how to shuffle vector in C++. Just Google that. I think the first hit will tell you how to shuffle vector in C++.
How to shuffle
Interesting.
Random shuffle. Oh.
You got an example there? So you just copy and paste that example and change the name to shuffle players. Did you get it?
No.
Or you share the browser page if possible, and then we can see it together.
Checking.
I get a STD and a shuffle.
Yeah. Thank you, Mark. Go on.
And the
how are you? Thank you.
Parentheses and STD begin with begin and another parentheses.
Oh, wait. He's got the okay. All right. Yeah, I think that's what Hoyan is saying. Yes, exactly. Thank you. Actually, that did give you the all right. Move mouse out of there. Tricky. Mouse out of there. Let's not cover that up. Okay. All right. Just go to the end of shuffle. The standard : shuffle. Hit a parentheses there. And then say sorted players.begin. Sorted _ players.begin.
It should be shuffle players, right?
Yeah, I'm sorry. Shuffle players .begin and shuffle players.
Shuffle players
.begin. I think it's dot begin, dot begin. It's a method.
Oh, I think it's begin and princess is shuffle player.
I'm sorry? Oh, yeah?
So
the next parameter is
and END. Yeah, that's it. I believe that should do it. No?
I think it should.
Return shuffle players at the end.
The example I showed, it had one more parameter, but I'm not sure what that was.
Oh, it did?
I shared the
One
link.
sec, okay. Just give me 1
Oh
second.
yeah, that seems right. Yeah.
They're both the same, random shuffle and shuffle. And then you can say, where's the call to it? Passing a generator. You don't need a generator. Generator is only needed if you don't want it to use a default generator. The generator is, hang on. All right. So that third parameter, Chris, that you're referring to is actually the generator used to generate the random numbers used for the shuffling. Otherwise, it'll use the internal random number, right? Okay. But you may not be happy with the internal uniform. You may say, I want to shuffle according to this distribution. And you can pass the generator.
So it's kind of like using SRAM, right?
It's kind of like using SRAM. Yes, exactly. A more fine-grained control. Right, you can even define distributions, specific distributions, and say this is how I want the thing to be generated. Okay, all right. So that's good. That's it. That should work. Right now, we've got a way of getting. So in your game class, if you go to your game class, right, in your game, in your constructor, the game constructor, no, we need an object. No, we just say one team, right? We just say one team. No, it was standard vector team. No, we just have a team object. We just say this game has a team object. So say team, team right there. Get rid of the standard vector. Get rid of that line completely. Get rid of all of the lines. Get rid of all of them. Yeah. Right. Now just say team, capital T. Yeah, space, team. Right? No, lowercase team. Team, semicolon there, and enter, semicolon enter. We'll just say, all right, so this is the team. And then maybe we'll have some comments up there too. So we'll know exactly what we're doing. Or people who are, will say, yeah. So the game consists of discovering the skill rankings of the players in this team.
Professor, will we need to add the team.h file here?
Yes, thank you so much. That's exactly, what we're missing, I think. Yeah, at the top, Chris is saying we should add hash include team.h. Or do it before, yeah. No, after is good. Yeah, I think it's up, no quote. It's single quotes, double quote team.h.
What?
Yeah, also that one. Right, and then put a blank line before our includes, so that yeah. All right, good. So team.h is included, and our game has a team inside of it. Everybody okay so far?
Yeah.
Right. And then we've also told people that the game is basically consists of discovering this. Okay. So in our constructor, the game constructor, I think on line 22, you already have this, right? Yeah. Now uncommented, we'll flesh it out. And in fact, we'll just have a default constructor. And I think let's not specify the team size for now. Let's say team sizes are always going to be 6 or something like that. So in our constructor, we're going to say, no, we don't even need a destructor, right? Technically speaking, we only need destructors. Here's a thumb rule, right? We only need destructors if you're allocating memory on the heap, right? 1 or 2, if you're manipulating things that are going to stick around even after your objects are gone, like static variables. Now, neither of those we're doing, right? Our program is squeaky clean, right? Everything is contained within tight boxes. We don't have anything outside. Yes or no? No globals, no statics, right? So we don't need destructors. And we're not using heap either, right? Everything is within our home in the stack. So we don't need destructors. So that's the great thing we have, advantage to our effect, right? So when we keep things simple. Okay, so game. So here, all we're going to do is initialize the default team, which I think is going to be, in fact, your team gets initialized. Team. Yeah, it'll get 6 players. Okay, can we look at the constructor for a team, the default constructor for team, if you don't mind, for a sec? The implementation, the team default constructor. I want to see what happens there in the default constructor.
Size.
In the CPP file. I'm so sorry. First one. Right, the constructor, go up furthermore. Right, even more to the, oh, these are private, the constructor, the further down, sorry, 20, line 33 onwards. Okay. All right, so if it's a default constructor, oh, it gets called with a single, with the default size. All right, here we're going to make a change, right? And ask questions about it in the forums, but it's going to be pretty straightforward. What happens if you want to have two kinds of constructors? One is a default, which doesn't take any parameters, and the other takes two parameter, team size, right? You have two constructors. So far, are we okay? If we do, we have two constructors, yes?
Yeah.
Okay, now the problem is, the two constructors for us are exactly the same, except that the one that doesn't take any parameters, we have a default value. That's the only thing, yes? So what we can do then is basically take advantage of the compiler writing it for us and say, we're going to have a default constructor, which is actually encoded as part of the non-default constructor by making the only parameter for the non-default constructor is going to be a default value, which means that if the parameter is given, call the non-default version. If the parameter is not given, call the default version without the parameter, right? So to do that, to get that effect. Yeah?
We're going to overload the constructor?
Yes, exactly. Thank you. That is called overloading constructor. Okay. So is everybody okay with that? When people talk about overloading constructors, that's exactly what they mean. And not only overload the constructor, we're going to overload it in a slightly different way, which makes it nice, right? At the end of size t size, say equals. No, at the end of size t colon on line 35, right? Inside the parentheses. Yeah, say equals, and then you say default team size right there, default team size. It has to be all uppercase, right? It is that thing that you define. Default team size. Why is it not auto-completing? Is everybody okay with this? Now, if you call team without any parameters, a default constructor, it will automatically get 6 players. You don't have to cycle through it and set each of the players, right? It's all. So when you say, give me a team, you've already got 6 players in there. Everybody okay?
Yeah.
So this
okay. Let's go back to the game class now. Let's go back to the game class, right? So we made a small tweak, which makes what we're doing in the game class easier, right? So now we've got a team. And it's got 6 players. We just need to find it. So in our game, let's define a public method called play, right? Play. Just define and we don't need the default constructor even, right? Because even the default constructor can be free. So get rid of line 19, 18 altogether, right? We can use the one the compiler gives us, which automatically freshes out team for us. If any of this is unclear, you have to ask, or at least chime in the Reddit or in your Discord forum. I don't have any evidence that you guys are on the same page as everybody else, right? So it is a bit of a struggle for me in that sense. So you got to tell me if any of this doesn't make sense. Find out, right? Or let me know. All right. So we've got everything set up now. As soon as what we need to do is the game class has one public method, and let's call it void. And let's say bool, because it's going to return success or fail. Play. And it's going to tell you whether it succeeded or failed, right? Play, and then let's take parameters. Say num int num or size t num tries, and you say again equals num tries TRIES, right? IES equals equals again. We're going to give it a default value here, right? Equals 10, right? Meaning that if you just say play, you get 10 tries by default, or you can say play 20, which means you get a play with 20 tries. Yeah. Okay, good. Now we can define play. I think maybe that's the only thing we have to do. Right? Go to play. To your game.cpp file. Game.cpp. Yeah. And then hash include game.h, and then we can start implementing. What is it? Game : play.
Oh, yeah, game.
Yeah. And it's not angle brackets, it's double quotes for include.
Oh.
Yeah. And then, and the parameter here is size t num tries, size t space num tries. And then you don't put the default value here, you only put it there. So it's only one place, so you don't confuse the compiler, right? So that's it. And then open, close. Yeah, all right, good. All right. So here, the first thing we're going to do is print out try number, right? So you say cout. And again, in game.cpp, we're going to interact with the user. So we need IOStream. So hash include IOStream and use namespace standard at the top. Not here in your game.cpp.
Oh,
In your game.cpp. No, not here. Oh, you got it already. And then also you have to hash include IOStream at the top. Yeah. And put it before game.h, right? Because the system one, ours will come later. And yeah, great. And then a blank line after that so that ours is separated from systems.
How did you switch them? Yeah, how did you switch the IOStream with the game age?
I'm sorry. How did I do what?
No, for the question is for Turkey. So how to switch them? Just.
Oh, Turkey. He's asking you something to do with VS Code.
Yeah,
what?
Switch what? You mean when I went here and copied?
Switch the IOStream and the game age. You just switch the places. Yeah.
If you select the whole line and if you hold Alt, you can just.
Oh. Okay,
wow! I didn't know that, Turkey. So that is cool. So you can actually move entire lines like that.
Yeah. You can move a whole block too.
I see.
Great.
Yeah, nice. Okay. All right, cool. Okay. All right. So the first thing we want to do, as soon as you start the game, is say this is round number, and then print. You do a loop, right? For n equals 0, for n equals 1 to n less than or equal to num tries. So we're going to do that many tries, that many rounds, right? N equals 1. N less than or equal to num tries. Because we have 1, we have to have less than or equal to on this side, right? Num tries, n plus plus. Yeah, okay, all right, good. So the body, and the first thing we do in the body is simply, the first thing you do is a round number, right? Round number. And cout. Cout round number. Cout, and then left shift. And then you say round number in uppercase, right? Round number. Yeah, number, and then space, and then that num tries, n, not num tries, n, and then endl. You can put two endls, right? Because and then you can underline that. You can put all bells and whistles there, right? You can decorate it and do all those things later. But here we don't want to use the effect, right? The effect should only come when the results are coming to you, right? Because that's when there's a suspense. If we use the suspense everywhere, then there's loses suspense, right? All right, good. All right, now your players. By the way, in your game, you need to have a list of players. That is your shuffled list. Okay, all right. So we actually do need a constructor. Turns out, because we need. I think I expected that we would at some point, right? So let's go back to the game.h and create a constructor. And in the constructor, what we're going to do is we have to maintain our list. The internal list, we don't know. We get the shuffle list and we store it. And then that shuffle list, we keep on tweaking by changing continuously, right? Suddenly the shuffle list is equal to the other list and we win. So far, okay? Is the game plan okay? Okay, all right. So in our game class, we need one more private member, all right? So make that vector of players, a vector of string, underscore members, right? Or I don't know what vector of string and call it something, right? A vector of string, call it players, or teamsters or players or whatever you want it. Yeah, players. No, players meaning, yeah, I think you should call it teamster for now, because player will confuse it with outside the team. We're also a player. Teamster, S-T-E-R. Teamsters, plural, right? Okay, so that is, and it's a lowercase v, by the way, it's not uppercase v. So it is in Java, maybe it's uppercase v, right? All right, good. So in our constructor, we need a constructor. Under public also have a constructor. Constructor. And copy the signature that we had for that constructor. Go to the CPP file. Did we have a constructor at all? No. All right. So create a constructor signature right there. We did one for team, right? So constructor right there. Game Game open close. That's fine. Game open close. Uppercase G. Uppercase G. Yeah, open close. All right. Now we're going to implement that. So go to the CPP file. Right now, because the constructor, let's put it right, yeah, before the other methods, right? On line 6, enter, hit line, yeah. Cool. All right, great. All right. So so in this constructor, let's put a comment at the top saying when the game constructor is invoked, we will have a team object. We will need to set our player list to the list of players in the team. Okay, all right, good. All right, so I think we got to write that in some way. Later on, you can paraphrase this, right, to make it sound better, right? When the game constructor is invoked, we need to set up our, actually, we'll just do it in code and it'll be more self-explanatory than writing a comment right now, right? We can write a better comment later, or one of you can help out later, okay? So let's go to the body of the code and flesh it in, and then it'll make a lot more sense. Right here, and it's got to be game : game, right? Game : because it belongs to the game class, right? Game : game. And in the body, we're going to say players. What do we call it? Players, right? Teamsters. Teamsters equals this arrow team, right? This arrow team. I don't know, the constructor. Can you have this in? No, you just say team, right? And also let's refactor it to say underscore team, right? Because it's private. Let's make all the underscore team and underscore. Make underscores for the private guys. And no this there, okay? Yeah. And Teamsters also needs to be underscore. I think this should work, right? Because yeah, and we'll figure it out later, right? So Teamsters equals Teamsters, underscore team dot get shuffled players. Is it get shuffled players? Okay, open close. All right, enter, right? Now, team has got an ordered list of players, okay? But it's given you a shuffled list of players. So now you can put a comment there, right? The game consists of discovering the order in the actual order from the shuffled list. List below, right? All right, so far, is everybody okay with this? Great. All right, now let's go to game.play, game:play, because now we've got the constructor and the team, right? So let's go to game:play. And here, what we're going to do is your current rankings are. No, that's fine. You need to see out there. And then on the next line, you say see out. On the next line. Oh, I'm sorry. That's what you're doing. Right. See out. Your current rankings are. Why did Alexa pick up all of a sudden? Your current rankings are a colon, right? And then you need new line after that. A new line, endl, I see, endl. If you're going to do a slash in, might as well put it inside of the original. Yeah. And you don't need the space before the slash in because you'll never get to see it, right? Great. Okay. All right. Now you can put a semicolon there because now you need a for loop to iterate over your Teamsters and print them all 1, 2, 3, 4, 5, 6, 7. Right? Yes? Yes or no? So now you can do for size t I equals 1. And we'll do the same trick we did last time, right? I is less than what is it? Teamsters.size. I is less than or equal to Teamsters.size. I++. Yeah, okay. And then what we're going to do is see out, and then I, and then a period and a space, and then what is it? You play Teamsters of I, and then end up, right? And you can put a tab in front too, so that it looks much better, right? So,
should we do?
Yeah, so double quote. So just type, type this in double quotes, and then /t for a tab. /t. No, I got to do \t. Right, there's a tab, and right after /t, you can say, there. All right. I. I, and then left shift. And then you need a dot and a space within quotes, right? Yeah, and then a left shift again, and then you want Teamsters, square bracket I, and then endl. Yeah, okay. Now,
Professor?
Yeah.
What is the /T?
/T is a tab character. When you hit the tab, it moves.
Oh.
Bam, like that. Yeah, /T is tab. It's ASCII value 8. No, maybe it's 9. I don't know. Is a tab. Everybody okay so far? We cool? All right.
Yeah.
Now, we said this is the round number. This is your current ranking. What we need to do is on the next line. Why is it's not indented? Good. And then one more blank line, right? Because now the for loop was basically current rankings should be attached to the previous line, so that's one block, right? So that's just fine. We'll clean it up later. Now what we need to do is choose player numbers to face off against each other. Choose the first player for a face off. Choose the number of the first player to face off, right? Just type it in, right? So C out. Choose, it's basically the prompt, right? See how choose the number of the first player to face off. Player to face off. No, face off, I think. I think it's 2 words. Yeah, and colon space. Yeah, semicolon right there. Colon space, space. Semicolon at the end. No, at the end. Right now, we want to accept from the user the number between 1 and Teamsters, right? So yeah, cin, and you need a variable. As soon as you enter the for loop, say inside the braces. No, inside the for loop. I think inside the for loop, you can say size t candidate 1, size t jk, or j and k, or T1, T2, K1. I don't know. Pick 2 numbers that are related. Yeah. All right. And also put in a blank line. Separate the declarations from the logic of your code by at least 1 line. It's usually better that way. All right. Now, no, it has to be. Is this the way to do CN? Yeah. Okay. All right. So is everybody okay with this so far? Now we also need to get the name of the second player. Right now, above both of those COUts, we want to comment, which is a to do for future students or for you, right? To do, say TODO, right? I think if it's all uppercase, it'll match the way VS Code will match it and will color it differently and all, right? Make all of them uppercase, TODO. Oh, didn't do it. Well, anyway, all right. Maybe it did for both. To do, what we want to do here is note the following is dangerous because we're not ensuring that the indices are within the bounds of Teamsters. Yes? So to do, meaning, go to the next line. Don't go to that. Yeah, the moment you go to, after ensuring, go to the next line. Yeah, all right, good. And then within bounds, so do bounds checking. You can say within bounds, full stop, and then do bounds checking is, no, that's fine. What you had before was fine. Within the bounds, yeah, okay. Teamsters, right? And then the actual to do item is do bounds checking, right? Full stop, yeah, or do bounds checking. That's fine. What you had before was fine. Okay, and then get rid of the to do on the previous one because the previous one is just a note. Okay, all right. So why isn't that not? Oh, only the to do is orange. Oh, that's cool because when you're scanning the file, it's easier to find out. All right, good. So is everybody okay with this so far?
Yeah.
All right, good. So now we're doing this dangerous step saying, well, we're going to assume that the user is going to enter something that is within bounds. So now we're going to do something and say, we have these 2 indices and we want to face these 2 players off. And we want to say, we want to ask the team. We want to ask the team a question. The team will now provide. We're going to go back to the team class and provide a method, right? I'm going to say, here are two players. Is player one better than player two? That is a question, right? We're asking for one bit of information. All right. So we're going to say, let's go back to the team method now, team class. We'll write the method and we'll come back here. Okay. We'll go back to the team. We are here already. So we want one more the public method and say, what shall we call it? We'll call it a bool. It has to return a bool. Bool. Let's say player one better. Is first player better? Is first player better? I think that's first player better. And that returns one or two, and it's all unambiguous, right? The reason I was deliberating there before, I guess I might as well tell you, is because I was thinking, oh, well, you know what? Maybe that method should be called something more traditional, like compare, right? Because you have dot compare or something like that. And I was thinking, well, you know what? Dot compare and all those things, even the standard library, sometimes we don't know. When you give it two parameters, we don't know. Copy, for example, right? Copy in the Unix system call, you give it two file names. But I have to look at the man page sometimes to know which is the destination, which is the source, right? Even in graph algorithms, sometimes we implement graph algorithms, you have to give destinations both integers, and you can't tell. And from the name of the function, you can tell which one is being passed first. And I think that you can reduce a great deal of cognitive load for someone who's reading the file by just looking at the function. They'll know, right? Is the first player better? There's no chance. So those are the ways in which you can make things easier for yourself down the road. Right. So all right, good. And then this has to take two string parameters as two string parameters, right? So string P1, string P2. Right. And again, this has got to be a const method. This is not going to change anything. Yeah, string P1, string P2. And then make this a const method also. Now we can go and implement this, right? So let's go to team.cpp and implement this, right? That is const, and then let's implement this. We're actually very close to finishing it up, right? It's very close to completion. And we got 7 minutes left, at least 7 minutes left, which is great. Okay. It's right. So I know it's got to be team : here because we're qualifying it, right? Team : is first player. Better. Okay. All right. Now all we have to do is find the index. How do we find out? Is you've got the sorted list of players. Yes, we have the sorted list of players. All we have to do is go through the sorted list one at a time, right? If you find the first player first, then it's true. If you find the second player first, then it's false. Yes or no?
Yeah.
Okay, let's do that, right? So for I equals 0, I is less than sorted players dot size, I plus plus. Is everybody following along?
Yeah.
And is this kind of class working for you in the sense that we're actually using all these concepts that we need to talk about, we're just bringing it in one by one? Is that okay? And we're actually working on a real project. But the disadvantage is that we run into bugs like this and we're thinking off the top of our heads and everybody's coding and then we get digressions, right? Which are sparked off by some of these, like random and stuff. Is that all okay with you guys?
Should I take the sorted player size here or?
Yeah. So sorted players. Then all you need to do is if sorted players of I equals first player, if equals P1, return true, right? The first line is in there. Yeah. If sorted players of I, square bracket I, space double equals P1, return true, right? The next line is going to be, if sorted players of I equals P2, return false.
Should we use the semicolon in the first line for the for loop?
One sec, how are we on? Okay, one sec. All right, all right. Now, return false. And at the end of the for loop, that's it, right? So we're just going through the loop. Now we're guaranteed to find one of the players in there. If we don't find either of the players in there, just return false for now, right?
So you're gonna want another equal sign on.
You want a space after the colon. You want a space after the colon before the plus I.
There you go.
All right, good. Wait, did it automatically? All right, cool. All right, cool. So at the end of the for loop, after the closing brace of the for loop, just return false, right? And we'll tag it and say unlikely situation when neither player is found in the list. Unlikely situation when neither player is found in the list. No C there, right? Unlikely situation when neither player, unlikely, L-I-K-E-L, yeah, situation when neither player is found in the list. Player, or player apostrophe S, player, yes, yeah, near player in this. All right, good. So is this okay? Everybody okay so far? Have we got the logic right? Okay, yeah. Now go to your game class now, and you can call this method, right? Game CPP. Yeah. Now you can say, now you can actually see out. You can see out saying facing off. See out blank line before, because it's going to be the action part of the movie, right? So yeah, see out, facing off, and then left shift. The name of the first player. The name of the first player is going to be. How do we get the name of the player? Yeah, we can get the name of the player. What is it? No, it's not Teamsters. It's Teamsters, isn't it? Teamsters. Yeah. Teamsters of P1. Yeah. Okay. And P2, right? And then we can have a drum roll or things like that. Okay. But yeah, left shift. Oh, I meant. I'm sorry. Hey, left shift. No, you need a and within quotes. And I'm playing. I'm facing off Mark and Turkey, right? Like that. You want and in uppercase. Yeah. You need spaces on both sides. Yeah, and then Teamsters of P2. And by the way, we're not going to change it now. Just keep a note in your mind for later. And it's perfectly understandable you did it now. Normally, after you cover pointers, right, next class, people will not use integer variables starting with a P. Right? Is a P1, usually people think it's a pointer. It's a pointer to something. All right, no, don't change anything now. All right, enter. All right, enter. Right? Now you're going to say if first player is better, if I think it's team dot first player is better, right? Team dot first. Why didn't it autocomplete? Is first player better? Is team dot is first. Why isn't it auto-completing? Hey, Turkey, why is it not auto-completing? You have a team. Why team that is first player is not auto-completing?
I think because it's not included. But it's
included. Include team.h. Oh, it's included in game.h. Team is included. Yeah. So it should know about team. It knows about team and it's not auto-completing is first player.
Let me see how to declare the team in here. Team.
No, it's declared in the header file, right? In the class.
Yeah, team.get. I see.
Oh, underscore team, not team.
Underscore team.
Dot. Now it should.
There you go.
Great. Yeah, P1 comma P2. Right. Now open brace and it's a body, right? Now we need braces there, right? Because this is going to be a significant. Not huge, right? 2 or 3 lines, but this is really the meat of the code, the game. Here, we're saying, well, we faced off 2 players. We know P1 and P2, right? In fact, P1 is better than P2. Is that right?
Mm-hmm.
Right? Now, what we want to do is, if the actual order of P1 and P2 in the original is different, we need to swap them. Yes? So how do we do that? We can say, you know what? Okay, here's the difficulty I'm thinking of, right? When
use the index from a find function, right?
No. So when we ask for 2 players, we need to give it 2 indices such that we think this one is better than that. And then the system can say, no, it's wrong, right? So we're just giving it 2 random players. For all we know, these 2 random players could be this way. Our P2 could be here, and P1, right? Our P2 could be inverted, and we don't get any information out saying, so what we need to do essentially here is that, we know that P1 is better than P2. Okay, all right, so here's what, yeah, that's fine, okay? So what we wanna do is, we know that P1 is better than P2. If the index of P2 is less than the index of P1, then you swap the two around, yes? Okay, all right, so here, so on that line, if type in if P2 is greater than P1, P2 is less than, because P2 is less than P1, but actually lost, so they need to be swapped, okay? If P2 is less than P1, then, then you say, or body, braces, braces, now you say, swap, what is it? What's it? Teamsters, P1, P2. Teamsters, comma, P1, P2. P2, and on the next line after this, you say, you can message that to the user. You say, see out, oh, here we have the result, right? We have the result of the thing. Well, what I wanted was, we want to display with effect here. But for now, we'll do a see out. Later on, you can look at the output and say, oh, well, I don't want a plain see out here. I want to display with effect. You can change this on your own later, right? Okay, so what was it? After the swapping, we say, what do we say here? We want to say P2 is less than P1. You want to say, you say player position swapped. Just say player position swapped. Position swapped. And you say, oh, you also want to say P1, right? You want to say P1 is P1 won this round. See out, P1 won this round, right? P1 won this round. Swapped, and before player, you can say P1 won this round. Yeah, I think that's better. Right? Before player. No, you want to say see out, left shift. And then the first thing you say, player. We don't want to say P1. We want to say Teamsters of P1 won this round, right? We want to say see out, Teamsters of P1 won this round, right? And then you want to say Teamsters of P1, Teamsters. Yeah, you got to get rid of the code. No, Teamsters square bracket, right? No, right. Delete everything. We'll start over, right? Delete everything. Leave the C out only. Okay, right. Type in lower underscore, Teamsters, square bracket P1, right? And then left shift, and then space won this round. Yeah, okay. And then period space, player team, we can say Teamster position swapped, player position swapped, right? Player positions swapped. Okay, this is the bit that eventually needs to be displayed with effect, colored. Okay, yeah, and done. Right, that's it. Semicolon. All right. Now, if P1 is if otherwise, no swap is needed. Yes, because faced off P1 is correct. Okay, so you see the else there. Else there is going to be else see out. Else you can say see out. Else you can say yes. Yes, Teamsters 1 is indeed better. Teamster 1, Teamster, well, whatever it is, right? That player won this round indeed, or something like that, right? No information gained. Essentially, that's what we want to say, right? Won this round as expected. As expected, whatever. All right, good. Right? You want to do the same thing for the other thing, right? So, and eventually after you do this, you can refactor this to make this code simpler, okay? So your next line after that.
Shouldn't line 41, shouldn't it be P2 instead of P1?
Yes, thank you. 1, and then there's a spelling error. Not there. Hey, the next one. Hey, no, hey, everything is fine. What were you saying, Mark? Looks all right to me so far.
Well, one of those should be P2, right?
Which one?
Either line 41 or 43.
No, they both. So you don't. It only gets into that if block if player one is better. That entire block. We're going to do the else block now, right? We're going to do the other block where P2 is better. So yeah, else you want to do the else for the outer if now. Else, yeah. You open a body.
Oh, okay. Sorry,
yeah, you can copy and paste the whole thing. Copy and paste the whole thing. Yeah, and then change the logic around so that it is P. Yeah. I think yeah, P1. Yeah, exactly. Right, and indent properly, and I think we're pretty much done here. Hang on, wait, we're not almost. It's indent, and yeah, everything okay? Block, okay. Okay, all right, and then at the end you want to do after the for loop you want to do if num tries is if n is greater than num tries return false. We want to compare. We want to compare, obviously, right? After the swap, at the end of these if statement, right? After the else, hit enter. Now you've done the swap. You have your teamsters that with the right swap in there, right? You want to check if this is the same as the Oracle list, right? So here we're going to call a function and say if team underscore team dot, I think we called it underscore team, right? Underscore team dot R rankings correct. R rankings correct. R underscore rankings underscore correct. R underscore rankings correct. Right? And then pass it your what is it? What do you call it? Teamsters. Pass it your teamsters. Right? Now we're going to write this method in team, right? And that is basically very simple, right? And then yeah, let's go and do it. Right? We can actually do it inline here. Right? Yeah. Do and this needs to return bool. Needs to return bool. And here's the cool thing, right? We don't even need a body. Don't leave this file, right? At the end, open a brace right there. We'll do this inline. What are you doing? I see. Yeah, just call it V. Just call it V or P or some just one letter name. One letter. Yeah. Okay. Good. All right. Now open a brace right there. Open a brace. No, semicolon. Open a brace. We'll do it inline, right? Space, left. No, not even next line, right? Yeah, space, left brace, space, return, V double equals, space double equals. Yeah, space double equals. Yeah, sorted players, semicolon. That's it. Yes?
You might want a STD on line 30 in the, yeah.
Oh, yeah. Okay. All right. Everybody okay? This is a one-line definition and it's done, right? So this method, when called, will just tell us if the vector we give us is the same as the sorted players. Yes or no? Right, now go back to your game class, we'll use it, right? If team ranking, our rankings correct, teamsters, all right? If the rankings are correct, then you say on the next line, you can drum roll, right? Display with effect or something like that, right? Display with effect, right? Oh, for now you do a see out, right? And you can do a to do, display with effect later, okay? See out, you say hooray, or congratulations, you've identified the correct ranking, right? And then break out of the loop, saying break. Not hooray, it's a H-O-O. Hey, we finished the game. We finished the implementation and it's actually going, right? Yeah, cool. Hey, what time is it now? Oh, well, it's like 9:59, but still it's under 10. That's great. Oh, and yeah, you want to say, hooray, you identified the correct ranking. Hooray, you identified the correct ranking in how many rounds, right? In N rounds. In using N face-offs, right? Using N face-offs. Using with N face-offs. With, oh yeah, all right. And yeah, face-offs. Yeah, right? A new line after that. And then you can put a to-do at the end saying, to-do, use display with effect. I don't know if you can put a comment and then the body of the statement. It should, right? Because this preprocessor will take care of it. But all the same, you can move that. Yeah, clean it up later, right? Because we're on time. We can clean that up later. Yeah. Don't clean up now. Don't. No. You can't use display with the effect. Yeah, if you use a display with the effect everywhere, you're basically screwed, right? Because the game will start looking very painful to play, right? You only want the display with effect for the final drum roll. Yes. Okay. All right. Good. All right. So all right. Now else, right? Else. If that's get rid of the comment there because the comment is breaking up the if block. Put the comment above the if maybe. Put the comment above the if. Yeah, okay, good. And a blank line before that because that's apart from everything else, right? No, the blank line before. Yeah, all right, good. All right, now else you want to see out. You know, I don't know. You want to say. Alas, or something like that, right? Alas, your match was useless. Alas, your round number n was useless, or something, right? Oh, you know, I don't know. Alas, or I don't know. Say something, right? Round n completed. Just say round n completed. Enter your next round, right? Round n completed. Enter the next round, right? And then it'll go back to the top of the loop and print the loop and everything, right? Enter the next round. Right, and all after that, and maybe two new lines. Yeah, 2 new lines. All right, and also get rid of the comma and put get rid of the comma and make that a semicolon. Or you can have a period, and then capitalize the E. I think that's fine. Capitalize the E. I think that's good, right? We've finished it, right? So when, we don't have a main, we don't have a main, right? But I can tell you what to do. We can continue to do that, but people will start dropping off now, and that's fine, okay? What we want to do in main is basically create a game class and call game.play. That's all, right? In main, we want to create a game class and call game.play. That's it, we're done, right? We no loops. Don't do it in the loop, right? You can call srand if you want, right? Get rid of the for and everything. Get rid of everything except the srand. Get rid of everything, right? You just say game, right? Game space lowercase game. And you want to include game.h at the top, right? Include game.h at the top. Yeah, and then get rid of team.h because game.h includes it, right? Get rid of team.h. All right, good. All right, great. Now game, and now game, and then say say game.play. On the next line, you say game.play. All right, that's it, guys. This is so cool, isn't it? We just, in the main, we created a game, we played the game, and the game object we'll call the play method. And in the play method, let's take a look at the play method. One more time, we'll just run it in our head, right? Right? And in our play method, it's going to print the round number. And then after printing the round number, it's going to get the 2 players and bam, bam, bam. It's going to, does it print the rankings? Does it print the current rankings? Do you have a for loop? Yeah, it does print. Yeah, no, actually, everything seems to be okay so far. Let's run it. Yeah, let's run it. I'm actually curious to see what happens. No, yeah, game.cpp also. Yeah, thank you. All right, okay. Let's fix these. These are all going to be very simple errors, by the way, okay? So let's go to the first one. Vector does not name a type. Where is this? Game.h. Let's go to your game.h. I think your namespace thing is missing. Yeah, standard colon. Yeah,
STD.
STD in front of the vector, STD in front of the string. Yeah, okay, all right, go. Now compile again, right? Just compile. All right, let's look at the first one. All right, the first error. All right, let's look at the first error. Where's the first one? Okay. Let's say no matching to what does it say? Oh, no shuffle. I maybe just call it random shuffle. Just call it random shuffle. Don't call it shuffle.
Or maybe you need STE shuffle.
Yeah, maybe STD double colon shuffle. Yes, thank you. But it was, I think it was in a file where we were using, it's a source file, right? CPP file. So we were using namespace. Just call it random shuffle. I think it's called random shuffle. Not here, in the CPP file. Yeah, there. Standard colon shuffle. Call it standard colon random underscore shuffle. On line 70, go to the beginning of lines. Yeah, on line 70, you see the word shuffle. Standard colon shuffle. Yeah, make that random underscore shuffle. I think it's called random underscore shuffle. So Chris was looking it up. Yeah, no, not random. Random. All right, good. Compile it now. I'm pretty sure it's random shuffle, right? All right, still other errors, right? But that's okay. Where is this? Team colon. Where is the? Oh, I see. It's saying there's no default constructor for team, but I thought we provided a default constructor. Where's a team.h file? Team.h file. Oh no, we have to say the team size equals default size. I thought I said that and we forgot to type it in, right? Yeah, after size. No, size t space size space equals yeah, default. I remember typing this in. Don't you guys remember typing this in? He had to auto complete. Right. Anyway, default size, default team size, or whatever that number is you had in your header file. Default team size. Yeah, there you go. Yeah, you did exactly that last time. I don't know. Or maybe we did it for name. I don't know. All right, go. Where's the first error? Maybe something's not saved. Hang on. Just equals default team size. You're doing things too fast. Hang on. What does it say? All right, default argument given for parameter 1. Okay. Previous. Oh, you have two specifications, 2 places. Why does it say you have 2 things here? You have one in 35 and line 27. You have 2 things. Where's line 35 and line 27? Oh, I'm so sorry, Turkey. My mistake, right? You don't put the equals thing in the definition. You put it in the declaration. Right?
Okay, I see.
Yeah. But I think it must have been missing in the declaration. Otherwise, you wouldn't see that error. Go back to go to the declaration. Go to the declaration. When you're in the header file, always check that too, right? Quickly.
Okay, so we do.
It is there. Okay, let's make sure. Okay, size t size equals default team size. Okay, that looks correct to me. So it has to give you both of the constructors. Okay, team.h is included here. Team, and when it tries to create a default game, it's going to create a default team. And what did it said it didn't find team.h? Is that right? No, what did it not find?
Let me run it again.
Run it again, compile. Yeah, let's take a look at the first error.
I think that fixed it. Now we have another error.
Why did we get the error the last time? I don't know. Maybe we didn't save or something.
Because it was declared here and.
Oh, I see. Thank you. Sorry. Okay. Size t long unsigned in. Team is first player. Are we not passing the right things there? Go back to the thing. Go back to your. Oh, we were passing the 2 strings, not 2 indices. We were passing it 2. Right. So yeah. All right. So we want to pass. What is it? Teamsters of P1 and Teamsters of P2, not P1 and P2.
Okay.
All right. On Teamsters of P1 and Teamsters of P2.
In game CPP, right?
In game.cpp.
Is first player here.
Oh no, not there. Yeah. Up online. Yeah, there you go.
Do we do Teamsters dot or
square bracket?
It's
a vector, right? It's a vector.
Yeah.
Square bracket P1, and then the other one is square bracket P2. All right. It's going to work here. Okay, before you compile, I'm willing to stick around until we get this compiled. All right, people are free to drop off. However, if you guys want to do it without my input, you should let me know, right? And I'll basically say that's fine. You guys fix it and share the code. Tell me what your preference is.
I honestly going to work on it to make it look shorter and later on. So, but I would like to finish the error to have.
You want to or you don't want to?
I do, but at the same time, I want to have like a functioning base before.
Oh yeah, sure. Let's get a functioning base and I'll give it to you. All right. Okay. Now, because all right. Here's a good way to, when it spits out like 500 lines of errors, you're lost, right now. So here's a good way. Compile the line program again. I'll show you something. Right. Compile the program again. Get the compile line again. Right. Compile the program line again. Right. And then space, and then vertical bar. right? And then say head space minus 20. That'll only show you the first 20 lines. So if there's 5,000 lines of errors, you won't get a, no, not minus space 20. Minus 20 is one word, or dash 20, not minus 20.
Oh,
right?
dash 20.
Dash 20. All right. Now you want to clear and print again. Print again. Yeah, clear. Enter. Oh, I see.
Wow.
All right. No. Get the same. Clear again. Get the line. I'll show you. Right. Right. At the end. Go to the end. And then space. Number two, greater than, ampersand 1. Okay, what this means, you don't have to remember or know any of this, right? What this means is that my program, which I'm running, is going to provide two kinds of output. One is going to the output stream, one is going to the error stream. Normally you take both of them and stick it on a console, but don't do that. Take the number 2 and put it in number 1. So there's only one stream coming out. So that now I have the ability to catch it one stream and catch only the first 10 lines or 20 lines. All right, so all of that we're doing by doing that. So don't worry. Okay, hit enter. Now you only see 20 lines. Yes?
I mean, still lines.
But we shall already run it. No, it's still not working. Right, no, hang on. Control G again. What shell is this? Yeah, go to the next command line. Echo space dollar uppercase shell. Dollar uppercase shell. All uppercase shell.
Fast.
Yeah. Get that command again. Up arrow. No, don't run it. The 2 greater than should go with the G++, not with the head. All right, just should go with the G++, not with the head. Yeah, 2. No, not there. No. After head.cpp, after game.cpp, you're saying this command should only produce one stream of output, not 2 streams of output. That's what we're saying, right? 2 greater than ampersand. All right, now you'll get only 20 lines.
There you go.
All right. Okay. All right. So we did all these, it's like a dance there to get, but all of this will become second nature. All right. So what's our error? Swap. No, I will write the swap function. Okay. Just go into your game. I can't be bothered looking for the swap in standard library, right? Just go into your game.cpp. We'll just write the swap function and it'll just do a global function, right? Where's your swap? Where are you calling swap?
Here.
All right, now go up to above this function. Just go above this function. Don't go all the way to the top. Just above this function. Above this function. No, not in the loop. Above the function. Oh, not the function call. Above the function. Above play. Get to the blank line and go above play. Above play. Yeah. Okay. Right. Good. Now we're going to define void swap. Void space swap, and then it has to take what is it? String. A vector of strings. Vector of string by reference, and then index 1 by reference. Was it index 1 by reference? Yeah, index 1 by reference, index 2 by reference.
Okay, so
N1 and 2, right? Yeah, I and J or whatever. Yeah, and then size TI, size TJ.
By reference, I.
No, they're just prototypes. You don't have to pass them by reference, right? And you're not going to change them, right? And all right. Now the body of swap is very simple, right? Let's just create the body of the swap, right? And put a blank line after swap so it's not stuck to play.
Backline?
Blank line after the closing brace so that it's not stuck to the. Okay, good. All right. Now all we are going to do here is interchange the 2, right? So we're going to say string temp equals vec of I. String temp equals vec of I, vec square I. Square bracket I. You lost your focus. Yeah. All right. Good. All right. And then vec I equals vec j and vec j equals temp. No, vec I equals vec j. You can't do the temp immediately, right? Vec I equals vec j because you got this and then that comes here and then temp goes there. So you're rotating things into place. Yeah, and vec of j equals temp. Right, that's a swap. It's all done now. I get rid of the spaces and everything, clean up and really good, right? So I think that should now compile. Get back to your compile place, your terminal, and compile again, right? And let's look at the first 10 lines.
Ooh.
All right.
Very
good.
small.
No, let's get rid of the head. We can look at the entire output. Run it again. and get rid of the and we'll just get get rid of the head, there. Yeah, backspace. Yeah, okay. All right, enter. We'll just get those 2 lines again. Right. Okay. Good. Now in member function play, no return statement. Okay. In non-void. No, hang on. You're moving things too fast. Hang on. Line 71. Go to line 71 on game.cpp. All right. Game.cpp. Oh, yeah. All right, this needs to return, right? So make it void play. Just make it void play. Oh, no, this has to return true or false, right? Okay, so what we need to do is at the end, you got to say, I'm sorry, you ran out of rounds, and then return false. At the end, you got to say, ran out of rounds and return false. We forgot to do that, right? Enter after the last, enter. And see out. Say, sorry, you ran out of rounds. Sorry, you ran out of rounds.
Professor?
Yeah, and then return false.
Can you hear me, Professor?
Yeah, I'm sorry. Yes, thank you.
I have to go. Can I ask
you? Oh, you're right. Thank you. Thank you for sticking around. We're done, by the way. We're done.
Yeah.
Turkey is going to post the code. You can all take it and play with it. Okay.
I just wanted to ask: is there a specific date you'll freeze the class?
Yeah, it's I posted it in the forums, right? It's a Monday before the finals, right? Monday of week 12. When I wake up, I'll just freeze, right?
So it's next week, right?
Unless you get to quest 9. If you get to quest 9, you finish quest 9. If you finish quest 9 anytime, right? Then you have until the Monday of the week after the final, right? So you mean you can finish the final on Thursday, but if you finish quest 9, then you can go back and get all the, revisit all the previous quests and get back those extra credit points, all these things you can do, right? You got an entire week for that.
Okay.
Good. Okay. All right. So it's going. And it's a team of only 4 players. All right, we got a segmentation fault. All right, that's fine. That's fine. Right now we've gotten past the compile time errors. The segmentation fault is because we're accessing the vector at an index that doesn't belong to us. Are we okay? Now I'm happy to stick around and debug this with you. You got to let me know, right? And it's going to be like 5 or 10 minutes. That's all. We can find the error and fix it. It'll take 5 minutes. However, it'll probably take you like 15 or 20 minutes or a half hour maybe to find it yourself. Which one do you want to do, right? If you want me to do it, we can do it, fix it now. And you can still have more work to do, right? After we fix it, you still have to take it and add bells and whistles and do all those things. You still have work to do. But if you want to fix it and do that, that's fine too, right? So you got to let me know. We're over time. I'm asking you the question.
I want to do it both because I feel like learning this segment fault is something core.
You want to do it? You want to do it in class?
No, I want to do it myself.
Let's do it in class. All right. Everybody okay with that? Everybody meaning, I think it's just you and Mark, by the way, Turkey, right? Everybody's gone. How are you understand? Are you guys okay with this? Mark?
I mean, I can work on it myself and get it as a learning opportunity because.
How about that? Since it's only the 2 of you, why don't the 2 of you try and fix it? And if you're totally stuck, I can leave the Zoom thing going, or you can just reach out to me, right? Just email me. I'll check my email, right? I'll get back on Zoom.
I mean, it's just doing the bound check, right?
I have a feeling it is just a bound check. We're accessing something that's not listed there.
You guys want me to stick around or go? Tell me.
You can go. We got it.
Yeah? All right. You can call me back, okay? Call me back if you want me to go. Can I just stop the Zoom and go? You can just fix it on your own, right? You can share it. Share it in Reddit.
I can start a session if anyone is free. I'm going to be working on it. I don't have a class today. So.
All right. If you need me to come back, we had a meeting this afternoon, which we're still waiting on some information before we schedule it, right? Chances are that I may have at least an hour free this afternoon, right? Which means that not this afternoon, 1 hour free in the afternoon means I can use that time anywhere. So just let me know. Just send me email. I'll be online within 10 or 15 minutes. Okay. All right. Thank you so much. Thank you all for your patience, Turkey especially, right? So you put up with all of my, go back and forth, this file and that file, having you jump around like this.
I enjoy it.
Thank you all so much for being patient, and I'll see you guys on a Tuesday. Yes.
Tuesday.
All right. Reach out to all the other guys, right? Because many of you are absent. Reach out, get Discord or have some discussion going, okay? On your own, it's not going to help much in 2A. All right, thank you so much. I'll see you guys next week. Have a good weekend. Bye.
Bye.
Yeah.